Welcome to Mathematics with Tom. I am Tom, and today we're going to take a look at the Laplace transform. So here's what it is. The Laplace transform of it's actually a transformation of an entire function. So the Laplace transform of some function, we'll call it f of t, is equal to the integral from 0 to infinity, of e to the minus st f of t dt. And here's the interesting part, and you'll see this as we start working with this more, is that the result is no longer a function of t. The t's get substituted by 0 and infinity, or limits at infinity, and then we're left with a function of s. And so we'd say that the Laplace transform of lowercase f of t, we're going to denote it as capital F of s. Now, so for example, if I took the Laplace transform of the function y of t, then that we would write that result as capital Y of s. Now, the first thing I'd like to show you is that the Laplace transform is what we call a linear operator. So let me write that. L, Laplace transform, is a linear operator. You may think, what in the world is that? Well, actually, the derivative, that's a linear operator. So is the integral. I'd like to show you why. And what that means is that if you take the Laplace transform of a scalar times some function of t plus another scalar, we'll call it d, times some function g of t, that's the same as taking c times the Laplace transform of f of t plus d times the Laplace transform of g of t. Okay, that's what it means to be a linear operator. And you've seen this before, so let's try it. How would we show this? Well, we would show it like this. So let's take the Laplace transform of all of that. So this would be the Laplace transform of all of that would be, I'll write it this way. So we're going to try this. The Laplace transform of c times f of t plus d times g of t is equal to the integral from 0 to infinity of all of that. So, e to the minus st times c times f of t plus d times g of t dt. Okay, let's do some simplifying now. Well, let's see, what do we get? I'm going to distribute the e to the minus st. This is the integral from 0 to infinity of, I'm going to get an e to the minus st times c times f of t plus, I'm going to get an e to the minus st times d times g of t, all of that dt. Okay, and let's come up here. We'll continue up above. This is equal to, this is the integral of a sum. Well, we can make that into the sum of integrals. So this is the integral from 0 to infinity of e to the minus st times c times f of t dt plus the integral from 0 to infinity of e to the minus st times d times g of t dt. Okay, and now let's do this. Oh, I can factor out these multipliers. So this is c times the integral from 0 to infinity of e to the minus st f of t dt plus d times the integral from 0 to infinity of e to the minus st g of t dt. Oh, but look at this. This right here, that is the Laplace transform of f. And the second integral, that's the Laplace transform of g. So look at what I found. I've said this is c times the Laplace transform of f of t plus d times the Laplace transform of g of t. And that is how we know that the Laplace transform is a linear operator. I hope that helps. Thanks for watching.